equations problem that has to do with a little side technique that we've seen before, but we haven't seen for a while. If I separate these, I'm going to get dy over y squared minus 1 is equal to dx over 2. So when I integrate that, I get stuck. Not on this side, that's just x over 2 plus c. But on this side, I get stuck. Because what's the antiderivative of 1 over y plus 1 over y minus 1? Do I even have a way to do that? Huh? Yes, partial fractions. Ooh, that's been a while since we've done that. 1 over y, 1 plus 0y over y plus 1, y minus 1. Yes, partial fractions. I even left myself a note. So I wouldn't forget. And it's going to be equal to a over y plus 1 plus b over y minus 1. What was our first step for doing that? Yep, cross multiply. So here, or just get the common denominator. Y plus 1, y plus 1. Y minus 1, y minus 1. So we'll have 1 plus 0y over y plus 1, y minus 1 is equal to ay minus a plus by plus b over y plus 1, y minus 1. You might want to consider grouping these into a plus b times y plus b minus a all over y plus 1, y minus 1. So what does 1 plus 0 times y over, what does the a plus b map to or connect to? What does that connect to? A plus b times y maps with what? Nope. 0, right? 0y is equal to a plus by. And then what does the b minus a map to? There's your 1. Yep. So then you have your two possibilities. You either have a plus b equals 0, excuse me, or negative a plus b is equal to 1. So if I add those up, I'll get 2b is equal to 1, or b is equal to 1/2. And what will a have to be to go a plus b equal to 0? Negative 1/2. So now, we think we're almost done here, but we're not. Now we have all that we need to do to integrate this. This is equal to the integration of 1 over 2 times y plus 1. And I think that was negative, wasn't it? dy. Plus the integral of 1 over 2 times y minus 1 dy. And that's going to be equal to x over 2 plus c. Then you integrate that, negative 1/2 natural log of y plus 1 plus 1/2 natural log of y minus 1 equal to x over 2 plus c. What do you want to do next? This looks kind of off. Huh? Yeah, we can do that. Do you mind if I multiply everything by negative 2 first? Is that okay? Okay. So this will just be the natural log of y plus 1 minus the natural log of y minus 1 equal to negative x plus a big C. It's like, doesn't matter, it's still a constant. You're right, it is minus, but we'll just make a big plus C. Yes. Okay, can I turn it around, maybe? No. Not in the least. It all works out. So you're going to get the natural log of y plus 1 over y minus 1 for negative x plus c. Now let's see if we can rearrange this now. Log base e, we can go e to the negative x plus c is equal to y plus 1 over y minus 1. Yeah, you may have had those flipped. I bet you had a positive x, didn't you? Let me finish, because this is the key part. Now I'm going to get e to the negative x times e to the c. Do you agree with that method? That property? Okay. And we're just going to call this, going to give it a name. We're going to just call it constant a. And so that's really all I can do. A e to the negative x is equal to y plus 1 over y minus 1. And you don't have to solve for y. This is great. This is great. That looked like a pretty easy separation of variable problem, didn't it? But it got pretty messy. That's separation of variables where you have to use partial fraction. Yeah.